Right now, somewhere out in space, there's a rock that doesn't know your name, doesn't care about your job, your family, or your Wi-Fi password. And if it showed up tomorrow, none of that would matter anymore. Here's the terrifying part. You wouldn't get a warning siren. You wouldn't get a countdown. You might just be sipping your coffee, scrolling your phone, when the sky itself catches fire. Welcome to the 24 hours that could destroy life on Earth as we know it. And by the end of this video, you'll understand why the biggest threat to humanity isn't the monster, a virus, or even ourselves. It's something so simple, so silent, that most people never think about it until it's too late. Let's start with the problem. Somewhere in the solar system, drifting quietly for millions of years, is a chunk of rock and metal a few kilometers wide. Not huge by cosmic standards, not even the biggest asteroid out there, but big enough that if it lined up with Earth's orbit at just the wrong moment, it would hit us like a bullet the size of a mountain. Now here's where it gets unsettling. Space is enormous. The odds of a direct hit are tiny, but tiny doesn't mean never. It's happened before. It will happen again. The only real question is when, and whether we'll be ready. So let's imagine you're living through it. Not in the far future. Today. This morning, actually. You wake up, normal day. Maybe you're annoyed your alarm went off too early. Somewhere on the other side of the planet, astronomers spot something new in the sky, a faint smudge of light that wasn't there a week ago. At first, it looks like nothing special. Space has plenty of smudges. But this wasn't even the biggest problem yet. As the hours pass, scientists run the numbers again and again, and the numbers keep getting worse. That smudge is moving, fast, and its path intersects with something very specific. Earth's orbit, at almost exactly the same time Earth will be there. By midday, alarms start ringing in observatories most people have never heard of. Not the movie kind of alarm, with flashing red lights and evacuation horns. Just quiet, controlled panic among scientists staring at spreadsheets and orbital models, doing the math that decides civilization's fate. Here's the part nobody talks about. By the time humanity would actually confirm a planet-killer asteroid is coming, we might only have hours, not years, to prepare. Movies love giving heroes months to build a spaceship. Reality is far less generous. So why was this such an enormous challenge for humans to face? Think about it. For almost all of human history, we had zero ability to even see these things coming. Ancient humans looked up at shooting stars and thought they were gods, omens, or magic. They had no telescopes, no calculations, no idea that a rock from space could end everything in an instant. If an asteroid had hit back then, nobody would understand why the sky turned to fire. Even today, with all our satellites and supercomputers, we've only mapped a fraction of the asteroids that could do serious damage. Picture the size of the ocean, now imagine trying to spot a single specific fish from an airplane. That's basically what asteroid hunters are doing every single night. And it's not just about seeing it, it's about doing something once you have. Here's a mind-bending fact. Humanity has never, not once, successfully redirected a large asteroid heading straight for us in a real emergency. We've tested the idea. In 2022, a spacecraft called DART slammed into a small asteroid moving through space just to see if it would nudge its path. It worked. The asteroid's orbit changed, just slightly, just enough to prove the theory. But that was a controlled experiment on a harmless space rock with years of planning. It wasn't a last-minute scramble against a countdown clock with billions of lives hanging on the balance. So how would humans actually try to solve this problem if it were real? The good news is, unlike almost every disaster in history, this is one we could actually see coming if we build the tools in time. Space agencies today track thousands of near-Earth objects, constantly updating models of their paths. If we spotted a dangerous asteroid early enough, say years in advance instead of hours, we wouldn't need Hollywood heroics. We'd need physics. A tiny nudge applied early changes everything. Push an asteroid off course by just a few centimeters per second when it's still millions of kilometers away, and by the time it reaches Earth's orbit, it misses by thousands of kilometers instead of scoring a direct hit. It's the same reason a slight turn of your steering wheel now avoids a wall a mile down the road, but the same turn attempted at the very last second does nothing. That's the plan. Spot it early, nudge it gently, avoid the apocalypse entirely. Boring, unglamorous, and incredibly effective, if we have enough warning time. But here's the twist. What if we don't? What happened next in our imagined scenario is even worse. Let's say the asteroid is spotted only hours before impact, too late for any spacecraft to reach it, too late for any clever nudging. In that case, humanity's options shrink dramatically. Evacuate the impact zone if we can even calculate exactly where it will hit. Brace coastlines for tsunamis if it lands in the ocean. Prepare for a shockwave that could flatten buildings for miles, followed by a dust cloud that blocks sunlight for months or even years afterwards. That last part is the real nightmare. It's not just the impact itself that's devastating, it's what comes after. Enough dust and debris thrown into the atmosphere can block sunlight enough to crash global temperatures, wreck crops, and starve ecosystems that took millions of years to build. This is basically what most scientists believe happened to the dinosaurs. Not the impact alone, but the years of cold, dark aftermath that followed. Let that sink in. The creatures that ruled this planet for 165 million years, far longer than humans have even existed, were wiped out not by outrunning fire, but by a winter that lasted long enough to collapse the entire food chain. And here's a surprising fact most people get wrong. It wasn't necessarily the biggest, scariest dinosaurs that survived best. Size didn't save you. Speed didn't save you. What actually mattered was how little food and warmth a species needed to survive the aftermath. Small, adaptable creatures, like the ancestors of today's mammals, made it through partly because they needed less to get by. Sound familiar? It's basically the ultimate lesson in don't be flashy, be efficient. This is where the story gets even stranger. Because here's the thing modern people constantly misunderstand about this entire scenario. They picture a massive space rock as some rare, exotic threat, like a monster movie villain. In reality, Earth gets hit by space debris literally every day. Small stuff mostly, pebbles and dust burning up harmlessly in the atmosphere as shooting stars. We're getting hit constantly. The difference between pretty light show and extinction-level event is simply a matter of size and luck. Another thing people get wrong. They assume scientists would obviously see a giant asteroid coming years in advance, like in the movies, with plenty of time for a dramatic space mission. The uncomfortable truth is that many dangerous-sized asteroids currently orbit in blind spots, hidden by the sun's glare or on orbits that rarely bring them close enough to spot easily. Some of the most dangerous ones could sneak up with very little warning at all. In fact, in 2013, a rock roughly the size of a 6-story building exploded over a Russian city called Chelyabinsk with zero warning. Nobody saw it until it lit up the sky brighter than the sun and shattered windows across the region with its shockwave, injuring over 1,000 people. That wasn't science fiction. That happened in your lifetime, and most people barely remember it. The real reason this all matters may surprise you. It's not really about asteroids at all. It's about us, about how humans respond to threats we can't immediately see, hear, or touch. We're incredible at reacting to danger right in front of us, a car swerving towards us, a fire alarm blaring. We're terrible at preparing for slow-moving, invisible threats that could be catastrophic but don't feel urgent yet. That's the big lesson hiding inside this entire terrifying scenario. The dinosaurs didn't die because nature was cruel. They died because they had no way to see it coming and no way to respond. Humans are the first species in the history of this planet with the actual ability to spot the threat early and do something about it. We built telescopes, we built spacecraft, we proved with DART that we can literally reach out and nudge the solar system. The only ingredient that's still missing is enough of us caring before it becomes an emergency. So here's the thought to leave you with. Somewhere out there, right now, there are still asteroids we haven't found, not because they're impossible to find, but because finding them isn't glamorous, isn't urgent feeling, and doesn't trend on social media, until suddenly it's the only thing that matters. Maybe the real story here isn't about asteroids at all. Maybe it's about us. About whether a species smart enough to build telescopes and spacecraft is also wise enough to fund and finish the job of protecting itself long before the countdown clock ever starts. Because next time, we might not get the warning at all. And the difference between interesting cosmic event and the day everything changed might come down to something as small as whether someone, somewhere, was looking up.